Right? So I'm just trying to explain to you that the starting point definitely related to the length of your line, as well as is related to the length of your pattern, right? It's basically related to both of them. That's why in our template, you will first get the length of your line as well as the length of your pattern, assuming those are all known already after those for loop. And now you're going to use those information to create your version of the reversed index finder. All right. Okay, please go ahead. The other thing is for our midterm exam, you can use your computer. However, I may not ask you. I may allow you to use your own IDE anymore. You have to use the online IDE because if you use VS Code, there's a lot of helping function. Right? You can just type one word; it will auto complete the rest of them. That's unfair to other people who is using this online compiler. I will give you a template just like the assignment. But yeah, I will. I want you to use the entire code to check the correctness of your code, right? Yeah, you just need to write a section of it, but I will provide you the whole thing for you to test. Yeah, yeah.
What would be the other questions, like an exam pack?
Yeah, there will be some multiple choice question, but majority is still this programming. Yeah. Again, very similar to your assignment as well as our in-class exercise. Yeah.
We can only use I because it's mostly the same if we just use I.
So instead of j equals to I, what?
Oh yeah, but
Yeah, this will keep changing. Yeah. Yeah, the other thing is you want to use both the length of the string and the length of the t as well, both of them, because this is not guarantee of 2 letter. Well, in this example, it's 2 letter long, but in reality, you can be any length of it, right? All right, so let's look at the answer. I mean, in the in-class activity, I will give you very few blocks to fill out. In the exam, you obviously have more block to fill out. So the first part, as I mentioned, you need to figure out where your starting point of your string, right? You could start with the length of your string, but that means you reaching the end of it, right? If it's s line minus 1. Instead, we also want to minus it by the length of your pattern, because we definitely know if your pattern take a few characters long, that means you shouldn't search the last few characters of your string. All right. From there, we're going to go backwards until we reach the beginning of your string, right? During the search, okay, we have another index j, which we copy over from the I, because inside this loop, we're going to change it after, right? We want to keep this I value unchanged for now. Inside the second loop, we'll have the j and the k. One is tracking the position of the s string. The other is for the t string. And we'll compare those two character, one after another. Until we reach the end of this t string, right? And if we ever reach it, that means we have matches everything in this t string, and we return this I position, just like the original find index. Right? Basically, essentially, the only difference here is this line. So we're doing this backwards. But to do this, you need to find how long your line is for that. Okay, again, I often provide you with a template code in our shared folder where you can test your code. Only copy over those things won't be enough. Will not be enough for you to test your code. All right. So most of our function we use so far return integer. So we could actually either explicitly saying our function will return integer as the int at the beginning, or if we just omit it, it will by default take that as integer. So by default value, it is always integer if you don't provide it. But always it's a good idea you provide whatever type you want, just to be clear, right? Definitely more than the integer, we can also return other things such as float or double. Here let's look at another example where we will want to return a double instead of integer in a function we have just tried. In previous exercise, we have made a function which is ASCII code to integer, right? So if we have a number, but it's like a character version of the number, we want to convert that number into the integer version of the number. So that works. But this time, we want to expand on that. So we will, instead of return an integer, we'll return a double, meaning that this number is like a string, while having decimal points inside. All right. So if you recall, what is our A to I look like? So essentially, the beginning part of it is almost the same as this one. First of all, we're skipping all the white space capture, and then we'll handle the signage, right? That's exactly the same as last time. Then convert the integer part. Again, this is very similar to what we have tried last time. We converting integer string into a real integer. We basically just getting one number at a time, right? And we add it onto our value variable. And then we, for every another digit, we will just multiply the previous value by 10. So we say 123 will get the 1 first, and then multiply by 10, and then add it to the 2, and then multiply those 12 by 10, and add the last digit 3, right? So this is the same, except our initial value here is 0.0 rather than 0 in our previous example from the previous lesson. That is the main differences. Now we want to handle the decimal point now. Right? In this particular case, because we're allowing for floating point or double in this case, so we will need to handle the decimal point. So if we find a decimal point, we'll just skip it because it don't do anything. But after that, we will need to process all the digits after the decimal points. So the first step is still the same. We will just multiply the value and add the another one. However, now our value is too big, so we're going to record that using another value called power. All right, the power starts from 1, and it will increment by 10 every time we read a digit after the decimal point. At the end, we will divide our whole value by this power, so we move this decimal point back. Does that make sense? Right, so let's say if we're reading a number 123.45, right? So at this point, our value will be 12,030 right? However, we have a power because we have 2 digit after the decimal, so our power is 100, right? So when we return the value, we'll divide the whole thing by 100 to move your decimal back to the correct position. All right. So again, this is very similar, except we having this power to record the decimal places. Yeah. So we can, with this function, we could potentially create our calculator. All right. So this is a very simple calculator which can only do addition, like a sum. So every time you enter a number, all right. So if every time you enter a number, so we'll get into this getLine loop, right? This getLine function we just looked at before. We'll get this line, and we put this line into the conversion function, right? It's converting this string of number into its floating point version, and then we add it to the sum, like sum start from the 0.0, add it to the sum, and then we print it out. All right. So, for example, our first entry is 1.11, so the output will be 1.11 because it's adding to the 0.0. And then if we enter 2.22, and it will output 3.33, right, which is the total of first two numbers we entered. All right, so this is a useful way to use the functions we just created, and also it demonstrates that the benefits of creating functions, right? Because this getLine function we have created for other exercise, we can also reuse it in this case. Although this calculator is not so useful, I would say, only doing adding. We will later on expand it, but this is a starting point. All right, so let's move on to the next exercise, which is to extend this conversion function by also handling the scientific notation. All right. So previously, our function can already handle 123.45. That is good, but it cannot handle the scientific notation. That's here e minus 6. Right. That essentially means we're going to move this decimal point to the left by 6 positions. Right. That means it should be 0.000. 1, 2, 5, 4, 3, 1, 2, 3, 4, 5. All right, so basically we just similar to the example we just saw, which is a way to handle this decimal point, right? After the decimal point, you then read every digit and append them to the value. Now we want to handle this e value afterwards, right? The e value afterward. Well, however, we do want to handle this case, the signage plus or minus could be different, and then the number afterwards. All right. So it's a further expansion to the function we just looked at. Here is a template. The first part is exactly the same as last time, or as the example I just showed you. I have created some spaces for you just for you to familiar with the original code. So basically you can simply look at the original code and find out what's being left over and just fill it out. Or you just fill it out if you already understand how to make it work. So on the second half of the page, see, until here, this only handles decimal points. All right. Afterwards, we want to handle this scientific notation. So we'll read if our input is a small or bigger e. If that's the case, we'll skip it. Then we'll determine if it's a positive or negative. Okay, I have already provided you with the code. You don't have to worry. But after that, you want to have a way to handle this exponential parts. All right, so basically you're just reading your exponential parts similar way as you reading the value itself, right? This is exact the same code underneath. Now you just want to read all your exponent parts. In terms of how to use these parts, you can essentially use a while loop, all right? And because let's say you have your exponential parts is 6, so if it's bigger than 0, you will multiply your value by 10 for every time you every digit you have. So you say you have 6 minus plus greater than 0. You multiply your value by 10, and then you decrement your 6 right into 5, and the 5 is still bigger than 0. You multiply it again, decrement it until it runs for 6 times. That means your value has been multiplied by 10 for 6 times, right? That's essentially how you do the power calculation. If it's a positive number, otherwise if it's a negative number, you will do the divide operation instead. All right, so 3 parts. First of all, fill out this previous example. This is exact same as the one example I just showed you. Second, figure out how to get your exponential value. And thirdly, how to use them in your while loop. Okay, I'm just going to show you the first part first. So you were supposed to fill out this first for loop to eliminate the white space, right? So you basically just increment your index if you encounter either white space or tab or new line, right? This is essentially the first thing you do. Second is to handle the digits, right? So because we want to convert the digital parts, so it only we only do that if that particular character are greater or equal than 0 or smaller or equal than 9, those 10 digits, right? So the second part is the same as the first one. Sorry, the third part is the first, same as the second part. So if we only want to handle digits in the fraction. All right, so here in the second part of our code, again, you want to have a way to handle this digits for exponent part. So you could use the expression we just look at for determining the digit, right? It's greater or equal than 0 or smaller or equal than 9 here. This last part is, again, as I mentioned, you need to repeat this while loop for multiple times based off what the value of your exponential number is, right? So I mean, if your exponential number is 6, so you repeat it for 6 times. If it's 10, you repeat it for 10 times, so on and so forth. And depends on your exponential sign, you will do multiply or divide. Okay, so this last part is just essentially this exponent minus minus, right? So you will use this value first to compare with 0, and after that you will decrement it by 1. So you will keep inside this while loop for as many times as your exponent value is. So this is another way to essentially just replacing the power function, which we don't have, that's building in C. All right. I mean, you could like write a new line here, exponent minus minus, and here you just compare exponent bigger than 0, and that's fine. Or you have this more compact version of it. Either way. Any questions so far? Let's do some